So the first question is, why are we actually wanting to have another shuttle kit when we've got two in the kit locker already? The automatic train controller is well provided in terms of facilities, but at a price, 34, almost 35 quid. The simple shuttle is what it says it is. It's simple. It just makes a loco go from one end to next and back, and stop at one end, then go back, stop at the other end, and so on. That's all it does. But it's also a very cheap price. So the Shuttle Plus, think of it as an in-between. It's much cheaper than the ATC and much more facilities than the PMK4. The kit of parts that I sent to the boys in North Wales came to £3.50 each. So for only roughly £1 more than the existing kit in the kit locker, you have a lot more facilities. It doesn't do all that the ATC can do for 35 quid, you wouldn't expect that, but I think it might do some things that the ATC won't do in the future. So let's start from there. What does it do? Well, it controls waiting times. The simple shuttle just goes back and forward, and there's a predetermined wait, roughly about 30 seconds. This kit will allow you to have the user setting the waiting times. It'll also support signal lights or semaphores, depending on what you've got in your layout. It'll operate points, as we'll see a bit later, as an option. You don't have to have them. You may just want a single bit of track and go back and forward and just have control over the waiting time. That's fine. So this idea is that the Shuttle Plus is expandable. You take what facilities you want from it. You might want them all. You might want just a basic shuttle. And it allows the ability to operate other features, crossing gates, sound players, etc. So that's the rationale behind the Shuttle Plus. That's the simple shuttle that you've all are familiar with. We've sold umpteen of these nationally. Simple relay operated by a 555 chip. And the components down here set the time of how much time it's on and how much time it's off. And the relay will just switch back and forward every 20 seconds or so, or 30 seconds rather, or so, reversing the power to the track. Very simple. There it is again. I thought, well, we can simply keep that same configuration, but it doesn't have to be a 555 here. Instead of having a 555 operate relay, why not have a microcontroller do it? In this case, I've used a PIC chip. It could be an ATmega, but I chose a PIC chip because it's more commonly available and used by more members. So if I replace that with a PIC chip, I can control the waiting time, like that. So I've taken out the 555, I've put in a PIC chip in its place. Unlike the 555, a PIC chip can't drive the relay direct, and therefore it has to have a transistor to switch it. So that's an additional component. The other additional component is the control for it. We've now got a little trimmer on board that we can tweak with a screwdriver to set the times for the waiting time at each end. So if that's all you want, that's worth the £1 alone extra. But it does much more. You can add signals. Signals could be signal lights, or it could be servos operating semaphore arms. Depends what your layout year it is, which you choose. It can handle both. If we're talking about LED lights, it's very simple. If you want a signal at the right-hand end of your layout, then you take it from pin 10 here. If you want a signal to operate on the left-hand side, you take it from pin 5. The chip's organized that all the left-hand activities happen on the left-hand side, all the right-hand outputs operate activities on the right-hand side. If you want to use LEDs, you just take one wire from the board to where the LEDs will be on the layout, as long as you have a 5-volt supply to take it to. If pin 10 goes high, then that means that here to here are both high, that won't light. But here to here has 5 volts across it, so that one lights. If pin 10 goes low, then here and here are both low. That won't illuminate. But now we've got 5 volts at one end and 0 volts at the other. That will illuminate. So one pin can handle 2 LEDs. You can opt to take the right-hand signal not to LEDs, but to a servo controller, which will operate semaphore arms. So now we've got control over lights or semaphores built into Shuttle Plus, and it's your choice. Again, we've added a second trimmer, which I've called the signal delay, which gives you the option. If you're using a semaphore arm, of course, it'll take longer for the arm to come up or down than it would to switch LEDs. So you can decide whether you want to use semaphore arms and give yourself an extra delay while the signal arm operates. So we've now covered time of movement and time over the signal operation. It also gives you the option to add TOTIs, train on track indicators. You can place them at where the train comes out of the siding, in preference to having timers. Timers are fixed. You can put in train detectors that lets you know when the train has passed. And that's an option that you can choose if you wish. There's the option link they've added in. With the link out, you use the timer. With the link in, a little jumper, you're going to have inputs from here and here. Pin 7 and 8 are configured as inputs. You'll notice that the 2 pins, one goes to your 5 volts and the other goes through a resistor. Why? Again, to give you options of what kind of train detector you want to use. You can use a simple light-dependent resistor. If you use a simple light-dependent resistor, then it's going to go between here and here. When the light changes, the voltage at this point here will change and be detected by the PIC chip. If you prefer other kinds of detectors, magnetic or the laser TOTI and so on, anything that goes from 5 volts down to 0 volts can be used as an input. Your choice. There's the options for points. If you wish, you can simply have a single piece of track. This can back and forward, very much like the basic PMK4, except it'll handle lights and timing. Or if you wish, you can put a point at one end. That lets you have 2 locos. One comes out, goes to the other end, stops, comes back. Points change. Second train comes out, stops at the other end and comes back. I've got a little video showing that a bit later. Or the third option is to have a point at either end, your choice. The kit does not include control of points directly. It's got outputs to control points. You'd have to have a points controller. An easy points kit or the Servo 4 kit, something like that. It's not built in. The control for it's built in, but the actual points controllers themselves are not built in, because you might want to use solenoids, you might want to use relays to operate tortoises. You can handle whatever you want depending on how you interface the outputs. There's the outputs for the points we've added into the mix now. So now we can control points and signals and the time for the traversing and the time for the signals to change with hardly any components really. That's if you wanted to have an external servo controller. Each of those tabs connects to a servo controller. So the right hand point output is going to go between 5 volts and 0 volts and act as a trigger for whatever servo controller you're using. This is the basic video I was telling you about. It's just a single bit of track with a point at one end and 2 locos traversing up and down. He's added in, as you'll see, the auto stop midway. So to see it working, I've actually speeded it up several times because you don't want to sit and wait as it sits at the station for a certain time, it sits at the other end for a certain time and so on. So it's a speeded up version. Let's just have a quick look at it. Auto stop stops it, gets to the end, waits its allotted time, whether you've set the trimmer to. And when that time expires, it's going to go back, hits the auto stop again, stops there for its allotted time. And you'll see when it gets to the end, the point changing. Click, point changed. And now the other loco will come out and do the exact same thing. It'll come down, stop at the auto stop. I won't play it all. I think you've got the idea. Let's look at a further option. I had a couple of pins up here that I thought we could use for auxiliaries. In other words, you decide what you want to do with it. You might want it to bring on a sound player, operate crossing gates, start an animation, whatever is your desire. So what you're looking at there is the set of parts for the current Shuttle Plus. Again, a very low component count really. You decide, I say, where the auxiliaries are used. Could be for other lights. The train comes into the station lights come on, or a man comes out, or you start a whole sequence of activities, or simple animations. The water crane comes round, whatever. You decide what you put on the auxiliary. The output just goes from high to low, and you can make that do what you want. There's the final setup. Let's take myself out of the picture. A pick controlling everything, operating the relay, which will then make the loco go back and forward. Optional totties here, if you want, train detectors here, control over lights, or going to a servo to operate semaphore arms, and outputs to operate the points via points controllers. I'm sure there's an auxiliary operating some sound player. So that's using all the facilities you get in Shuttle Plus. And before you turn on the power, that's how you place the various locos, depending on whether you're using one loco, the single track, or one loco that goes into one siding, into another, into the top, into the bottom, or whether you have a couple of locos that are traversing one at a time, back and forward. Again, your choice. Here's another speeded up one I did for Wozag some time ago. Let's have a look. As you can see, I'm just using easy points here to operate the servers for the points. Okay, I think you've probably got the sequence. Now, I'm showing that with points and sidings that are visible at either end, which is an option you might want on an exhibition layout or your own layout at home. Or you might want the track to be a certain length and then curve backwards, disappear under a mountain or whatever. So you only see the track. And that way you see one train coming out of one tunnel, then to the other, and then a different train coming out, a different train coming out, and so on. It's your choice whether you want to have these pieces visible or not. There's the board for it. Most of you have now got one in your hands or will have soon. The kit doesn't come with connectors because they're expensive. It's your choice whether you want to fit 2-pin screw connectors here or just, personally, I always just solder onto these, find them more secure. It's your choice. So you have your power coming in. That's the power for the traction, that is, from a controller, and going back out to the track and being switched with a relay in terms of its polarity. Up the top is the 12-volt supply to power the whole thing. And down the left-hand side, you've got auxiliary 1, all the left-hand activities, the signals, the points, the train detectors, and down the right, you have the outputs for auxiliary 2 and the right-hand signal, point, train detector. And there's your 2 user adjustments, one for the delay of the traction, the stopping time, in other words, and one for the delay for the signal. That's what it looks like built. There's the connections to it. I said earlier to some of you, I've got a 7-page PDF that covers the construction and tweaking of this. We'll take an example of control. Let's say your piece of track and the speed you want to run it at would mean the loco would take 20 seconds to get from A to B, from one side to the other. And let's say you've set the delay trimmer to 45 seconds. Then it means it'll take 20 seconds to get to the end, but there's 25 seconds still to go. And then the points will take 8 seconds to allow for slow movement of points. And the signal may take 7 seconds if it's got another servo. So in this example, the loco is going to stay at one end for 40 seconds. And if you want it to rest there for a shorter time, you simply adjust the delay. If you want it to rest there for a longer time, you simply tweak the trimmer further. So what is the future option? Or options? Right. It struck me that if we want to control the traction, we could replace the relay with an L293D. I'll explain how that works in a minute. But what it does, it obviates the need for a separate speed controller. It also gives us the opportunity to add in acceleration and deceleration, which is something you get in the 35-pound version. And also, still to experiment with this bit of it, also allows me some scope over the frequency of the pulse width modulation. I did a talk previously about motors and PWM and noted the wide range of frequencies that various motors performed better at, made multiple tests. I thought it'd be handy if we had some control not only over the movement back and forward, but the acceleration rate, the deceleration rate, and even the frequency, so you can tweak it to your particular motor that's doing the traversing back and forward. So I'm using the 293D, costs £1.49, not much more expensive than the relay. What's the benefits? Well, the 293D is a driver chip, and down the middle, the left-hand side works independent from the right-hand side. If you put a motor between pin 14 and pin 11, then what you can do is have two inputs. And if you make output 4 go high and make output 3 go low, the motor will spin in one direction. And if you reverse the polarity of pins 11 and 14, it'll spin the other direction. So now we can control the direction of the loco simply from the pick controlling input 15 and 10. It needs 5 volts to power the internals of the chip, but the motor voltage that comes in is chosen to match the motor you're using. In our case, we're using 12-volt motors. We put in 12 volts here. And as it stands, if we made one high and one low, the motor will scalp along at the fastest possible speed because you put 12 volts across it in one direction or the other, depending on the polarity of the inputs. But the trick is it's also got what's called an enable pin. So if the enable pin isn't enabled, nothing works. It's as if you just switched it off. So think of that as putting the power on up the top, but you've an on and off switch here, essentially, that controls whatever happens. So far, so good. There's the logic for it. If you make 2 of the pins, there's the enable. It has to be high to work at all. If you bring that pin low, nothing happens. So if you make it high and you make one pin high, one pin low, turns to the right. Reverse the two, turns to the left. And you'll notice if they're both the same, if they're both taken to low or both taken to high, the motor just stops. It only turns when the two pins have got different voltages on them. We'll take advantage of that in a minute. Like that. If instead of having 5 volts here for the enable, I feed it with pulse width modulation, then what I've got is 12 volts coming in from the motor voltage. So there's 12 volts across the motor, but only as a series of pulses. So we can now control not only the direction of the motor or the loco, but the speed of the loco using a 293D. That's the plan. There's PWM for those that don't know it. It just means you've always got 12 volts going to the motor, but not all the time. If you give it very short pulses of 12 volts, then the total current is much reduced. You get a slow speed. If it's on half the time at 12 volts and half the time at 0 volts, well, you only get half the power really into the motor, so it's mid-speed. And if it's nearly always at 12 volts, in other words, wide pulses, you get a fast speed. So all I need to do is get the PIC chip to change the width of the pulses going into the 293D. And if I do that, if I change the pulse widths, then I control the speed. Okay. This particular iteration doesn't use fixed time, that uses a train detector. It needs a train detector. I've left in the diodes there. It doesn't need them if you're careful. In other words, if you set it to stop at this point here correctly, it'll stop. If you set it incorrectly, it falls off the end of your desk. So you can still use the diode as a fail-safe. And I would probably recommend you had that for the sake of pennies. It's worth it. But this version also allows for one mid-stop with other train detectors. They're optional. If you don't want to stop midway, don't fit them. If you do, it means the train will come along a bit like the auto stop. When the train gets to that point there, it's detected. The reason there's two is if a train's coming in from one direction, you want it to be fully in the platform before it stops. So if it's coming in, say, from the right, you don't want to stop here, you want to stop there. So you want that detector to notice that it's coming in that direction and stop the train with the engine there and the carriages there. If it's coming rightwards from here, you want this detector to spot it and stop with the loco here and the train there. So you could control mid-stop. We've now got 4 user settings. The dwell, in other words, the speed, sorry, the time it takes to get from A to B and the stopping time combined. I use dwell because that's what the ATC uses for its journey time. So another little trimmer that will set the maximum speed. So that tells you that although the PWM will be doing the acceleration and deceleration, it's from a particular maximum width of pulse. So we can now do acceleration and deceleration. Well, I hope I can. I'll have a go at it. And also the ability to change over a limited amount, say between, I don't know, 10 hertz and a kilohertz or something like that. I'll be able to change the frequency of the PWM, and that would affect quite a range of different locos, different motors. Now, we've got a mid-stop, but we've only got two auxiliaries, not enough pins for an auxiliary for the mid-stop. I've got a left-hand auxiliary, got a right-hand auxiliary. They can have different activities at either side. One could be lights, one could be audio, whatever your choice is. But there's not enough pins to do a mid-auxiliary. But you probably remember earlier I said there's an occasion where two pins going low stops the motor and two pins going high stop the motor. So if I always stop the motor with two lows, I can detect two highs to do the mid auxiliary. So by adding in 1, 2, 3, 4, another 5 components, cost pennies actually, then I'm able to have activity not just on the left and the right, but also when you stop the train in the middle. So some independent sounds or activities, left hand, right hand, or mid-stop. And there's your controller for the dwell, your maximum speed, your acceleration rate, and PWM frequency. These dotted lines indicate that when I get to a PCB, pins 2 and 5 will be commoned up. 3 and 4 will be commoned up. You remember I said earlier that the 293D had two separate groups. They can work independently. If I parallel them both up, I get almost twice the current capacity. So it lets me handle N gauge up to probably O gauge from the 283D. That's as far as I've got so far. Got a board, my 12 volts coming in, my 4 pots. Down the right hand side, you'll see various LEDs that are meant to represent the signals, the points, the auxiliaries, and so on. And then over here I've got 4 push buttons that represent the 4 train detectors. And down the bottom will be the 293 for the pulse width modulation going out to here to the track. So we're going to end up fairly similar to a lot of the facilities you get on the ATC, but acceleration, deceleration, waiting time, speed, and so on, but also auxiliary outputs, and also hopefully changing the PWM. So we're adding extra facilities, and it should end up sitting price-wise nearer the cheap one than the dear one, but do much the same as the ATC. And that's it, folks. That's where I'm at.